Have you ever landed on a website where, one part feels incredibly slick and responsive, while another section, maybe even on the same page, is just clunky, slow, or feels jarringly different?
Yeah, or maybe you've been on a big engineering team trying to build one massive application and, well, constantly bumping into each other's code.
Exactly. And while you're probably familiar with backend microservices, that idea has been around a while. There's a similar, really transformative movement happening right now in the front end world.
It really is fundamentally reshaping how we architect and deliver complex user interfaces.
Hmm.
We're talking about, breaking down those huge monolithic front ends into smaller, more manageable pieces.
And that's precisely our quest today, a deep dive into microfrontends. We're going to unpack how they're changing the game for building and deploying these complex UIs, looking at everything from the basic ideas to the cutting edge stuff.
hmm Our guide for this is a great set of insights from how microfrontends work, from iframes to module federation by Rahul Gupta.
So, our mission here is to really demystify what microfrontends are. We want to explore the different ways people have implemented them, both, traditionally and with the newer approaches.
And uncover the key factors you need to think about when you're evaluating if they're right for your needs. We'll pull out the core knowledge, maybe highlight some surprising bits, and get to those aha moments, but hopefully without getting bogged down in jargon.
Right. And as we look at the history, you might be surprised some of those, let's call them traditional methods. They seem simple on the surface, but they actually come with some pretty significant limitations we often overlook.
Yeah, but we'll also get into a modern approach called module federation. It's
Mm.
emerging as a really powerful, flexible solution.
Though, like any powerful tool, it's got its own interesting challenges, right?
Definitely. Worth exploring.
Okay, let's dive in. So, to start, let's just nail down a clear definition. What are microfrontends? If backend microservices make sense to you.
Think of this as the front-end equivalent, basically. The core idea is shifting away from one giant single UI code base towards a collection of decoupled UI code bases.
Decoupled being the key word there.
Absolutely. And the real power comes when those decoupled pieces are managed and, importantly, deployed by totally separate teams. That fosters a level of autonomy that's just, well, it's almost impossible in a big monolith.
But for the user, it still feels like one single cohesive website or application, right?
Exactly. That's the goal. And the why behind it is pretty compelling. It can dramatically boost team autonomy, significantly reduce deployment risks because you're only deploying small pieces, and it really helps you scale development across multiple teams.
So each team can kind of own its own tech stack
Yeah,
and its own release schedule.
precisely. On their stack, their deployment cadence, their whole workflow.
Okay, so when we talk about these pieces of UI, what are we actually talking about? It sounds a bit abstract. The source material, Rahul Gupta's work, gives some really good concrete examples, like they can be entire pages.
Right. You could have, say, an authentication team that owns the login and sign-up pages completely.
And maybe a totally separate engagement team owns all the marketing pages. Each is its own micro front end.
Or they can be smaller, more granular things, components. Think about a header or a footer.
Ah, yeah, something that needs to be consistent across the whole site.
Exactly. Consistent, but maybe integrated by different teams who own different sets of pages. That header component could be a microfrontend itself.
Okay, pages, components. Oh, what else? The source mentions widgets too.
Yeah, like a recommendation widget you might see on an e-commerce site.
Hmm.
A dedicated recommendations team could own that widget entirely.
So it gets embedded in different parts of the site, but it's owned by one team.
Right. And unlike maybe a static component, it often needs to fetch its own dynamic data from APIs. APIs probably also owned by that same recommendations team.
Gotcha. So it's not just a static bit of UI. It's like a self-contained, often dynamic, functional unit.
It really shows how flexible microfrontends can be. Teams can own anything from a whole page down to a dynamic little widget.
Yeah.
That flexibility is, well, is what developers have been chasing.
Which leads us nicely into exploring how people have tried to achieve this historically,
Okay.
because the idea isn't totally brand new, is it?
Not entirely. While things like module federation feel new, the core concept of splitting up front ends has been tackled before. Many places are probably already using what the source call traditional approaches, maybe without even using the term microfrontends.
Okay, like what's a common traditional approach?
Well, one of the most common is server-side composition. This is where you split the website based on URL patterns, essentially.
Okay, so like everything under account goes to one UI service and blog goes to another.
Exactly. And this routing usually happens at a reverse proxy layer, something like NGINX, which just directs the traffic based on the path.
The big advantage there seems obvious. Independent deployments for those sections.
Definitely a pro. But the downsides can be pretty noticeable for the user experience. It often forces full-page reloads when you navigate between those sections.
Which doesn't feel very modern, not like a smooth, single-page app.
Not at all. And you often end up duplicating things like headers and footers across those different sections just to keep things looking consistent. Plus, it's really limited to splitting by route. You can't easily integrate smaller pieces within a page this way.
Right. Okay, what else is in the traditional toolkit? I feel like Iframes have to come up here.
Yes, the humble iframe.
Yeah.
Using that tag to literally load another website as part of your own page.
Yeah.
You see it all the time for embedding things like, Twitter feeds or Google Maps.
And it does let you integrate widgets within pages, not just whole pages. And it keeps the content isolated. Seems simple.
Simple to integrate, perhaps, but the source is very clear on this. Iframes come with, and I quote, significant limitations. They are generally not recommended for your core micro-frontend strategy.
Wow, okay. Why such a strong warning?
Well, first, you get completely isolated loading. That iframe loads entirely separately, which often means slower overall page loads.
Yeah.
Then you hit constant headaches with things like authentication cookies not being shared easily between the main page and the iframe.
Ugh, I can imagine. Layout problems, too.
Oh, yeah. Getting iframes to size and behave predictably within your layout can be a real pain. Plus, you run into cross-domain security restrictions all the time.
And I bet SEO and accessibility take a hit, too.
Big time. Search engines can struggle with iframe content, and making them accessible is often much harder. Really, they're best suited for embedding specific third-party content, not for building the core parts of your own application UI.
Okay, message received. Avoid iframes for core architecture. So what's the last traditional approach mentioned?
The final one is build time integration, usually done through packages. Think of this like one team publishing reusable UI components as, say, an NPM package, a UI library.
And then other applications just install that package like any other dependency.
Exactly. They pull in that component during their NPM install phase. It gets bundled together with the rest of their application code and then shipped to the user as one big JavaScript module. Useful for sharing full apps, widgets, or even just static components.
Okay, the upside seems to be that the components are built together, shipped as one coherent thing.
True, but the big catch, deployments are tightly coupled. If the team updates that shared UI library package,
Then every single application using it has to update to the new version of the package and redeploy their entire application.
precisely. That creates a huge amount of effort around publishing, maintaining versions, dealing with potential conflicts between different versions. It's a whole coordination nightmare.
And I guess you also risk bloating your final application bundle if multiple packages pull in slightly different versions of the same underlying dependency, right? Like two versions of React.
Exactly. Duplicate dependencies are a real risk. So while it offers some modularity, it's definitely not true independent development and deployment.
So yeah, these traditional methods gave us a glimpse of modularity, but they clearly came with trade-offs. Clunky UX, coupled deployments, versioning hell.
Which naturally led people to search for something better, more elegant.
And that brings us to the modern era, and specifically module federation. This sounds like the real game changer.
It really is a key modern pattern. It started as a Webpack 5 feature, but it's evolved. Now there's Module Federation 2.0, which supports other bundlers too, like RSPack and Vite.
And its core strength, the big difference.
The absolute game changer is integrating remote UI pieces at runtime. Not at build time like packages, but live in the user's browser.
Okay, runtime integration, let's unpack that. The source uses a good example, a blog application and a separate recommendation widget.
Right, so imagine a content team owns the blog application, and a separate recommendations team owns a dynamic recommendation widget. The content team wants to pull that widget into their blog pages seamlessly.
So in module federation terms, the recommendations team's widget code is the remote.
Exactly. They're the team exposing JavaScript files, their widget component, for others to consume. They configure their build to say, hey, this widget is available.
And how does the blog find it? That's the remote entry.
Correct. The remote entry is basically a URL, like a manifest file, that lists all the JavaScript files the remote is exposing. Module federation typically generates a file called remoteentry.js for this. So it might be something like https:/recommendation.com/remoteentry.js.
And the blog application, owned by the content team, is the host.
Yes, the host is the independent website that consumes these remote files. The host team configures their build to know about the recommendation team's remote entry URL. They essentially link to that remoteentry.js.
Okay, now the really clever part seems to be the shared dependencies bit. This is about
Yeah,
performance, right?
absolutely crucial for performance and a major innovation.
Mm.
Both the host, the blog, and the remote, the widget, can declare common dependencies they use, think React, or maybe a shared design system library.
And Module Federation figures out how to share them at runtime.
Exactly. It automatically negotiates. If the host already has React loaded, the remote won't download it again. It just uses the host's version. This prevents downloading duplicate code, which is key for keeping things fast.
And you mentioned needing to mark some as singleton, like React.
Yes, that's critical for libraries like React. React relies on having just one single instance running on the page to manage its state correctly, especially with hooks. If you accidentally loaded two different versions of React,
Things would break spectacularly.
right, so you mark it as a singleton in the configuration, and Module Federation ensures only one instance is ever loaded. Super important.
And then for the developer on the host team, how do they actually use the remote widget?
That's the beauty of seamless usage. The developer on the blog team can literally just import the recommendation widget component as if it were a local file right there in their own code.
Seriously, like import recommendation widget from recommendations widget.
Pretty much exactly like that, depending on the configuration names. Module Federation handles all the complex stitching behind the scenes at runtime. It fetches the remote entry, figures out the shared dependencies, and makes that remote component available, just like magic.
Wow. So in a nutshell, Module Federation is about fetching JS code components, pages, whatever, from a remote server live at runtime.
While still being able to share dependencies efficiently and keep performance high, it's a really powerful way to build truly composable UIs.
It sounds like a profound shift for scaling front-end development in large organizations. Teams can really own their feature, deploy it independently.
And innovate on their piece of the UI without creating a bottleneck for the whole application. That's the dream, really.
Now, when you research Microfrontends, another name often pops up, single SPA. Where does that fit in? If Module Federation handles the code loading, what's single SPA's job?
That's a really good question because it highlights an important distinction. Single SPA has a very specific primary use case. It's mainly designed for integrating components or even full applications that are built using different JavaScript frameworks.
Ah, okay. So like if you need to run some React components, maybe an old Angular section and a new Vue feature all together in the same single page application.
Exactly that scenario.
Yeah.
Single SPA acts like a high-level JavaScript router or orchestrator. It manages the lifecycle's mounting and unmounting these entire framework-specific applications based on the URL routes. It makes sure they can coexist.
So it's like the conductor of the orchestra, making sure the React violins and the Angular cellos play nicely together.
That's a great analogy. But critically, it doesn't solve the problem of how to get the code for those different instruments into the browser in the first place.
Right. So it's the orchestrator, but it still needs a delivery mechanism.
Precisely. Single SPA needs to be paired with something like Module Federation for runtime loading, or even the older build time package approach to actually load the remote code for those different framework apps. It handles the coordination, not the code delivery itself.
Which leads to a pretty clear conclusion then. If your whole organization, or at least all the parts of the app you're integrating, use the same framework, say everyone's on React.
Then using Module Federation directly is often the simpler and better path. Single SPA adds an extra layer of complexity that's really only justified if you have that genuine need to mix multiple frameworks within one seamless user experience.
Makes sense. Use the right tool for the job. Okay, so Module Federation sounds incredibly powerful, a real leap forward. But there's always a but, isn't there?
Usually. Like any sophisticated tool, it definitely comes with its own set of trade-offs and real-world challenges teams need to be aware of.
Let's get into the practical side. What are the main hurdles? The source mentions the initial setup effort can be high.
It can be, yeah. Depending on how your application build process is currently set up, getting Module Federation configured correctly can take significant effort. It often requires a, let's say, deeper understanding of your bundler's internals, like how Webpack 5 handles code splitting and chunk optimization. It's not just plug and play initially.
Okay, so there's a learning curve. What about ongoing challenges? We talked about shared dependencies.
Right. Shared dependencies management is crucial and ongoing. You really need to be meticulous about reviewing which dependencies can and should be shared between your host and remotes. Getting this wrong hurts performance.
And getting the singleton configuration right for libraries like React is non-negotiable.
Absolutely critical to prevent those weird runtime conflicts and ensure everything behaves predictably. It requires careful configuration and testing.
Okay, what about challenges that pop up at runtime when the user is actually interacting with the site?
Well, cross-domain issues are a common one.
Hmm.
If your remote microfrontend is hosted on a different subdomain than the main host application.
Which is pretty likely in a real setup.
Yeah. Then you need to make sure cores, cross-origin resource sharing headers, are configured correctly on the server hosting the remote, allowing the host domain to fetch its code and data.
And authentication cookies need special handling too.
Definitely. You need to configure your fetch requests with the right credentials option so the browser actually sends the necessary cookies across those different subdomains to keep the user logged in. It trips people up.
Okay, cores and credentials. What else? Oh, styling. I can just imagine the CSS chaos.
The developer equivalent of mixing Legos and Duplos, hoping they fit. Yes, styling conflicts are a huge potential issue.
How do you stop the remote widget styles from breaking the main layout or inheriting weird styles from the host page?
You need robust strategies. The source suggests things like using CSS and JS libraries like styled components, which automatically scope styles, or CSS modules, or ideally having a really well-designed, properly scoped design system that all microfrontends adhere to. Without that discipline, yes, CSS can become a mess.
And finally, what about the operational concerns, like monitoring and deployment?
Good point. Observability and analytics get more complex. Because there isn't one single index.html file rendering everything, you have code running from multiple different sources, remotes.
So how do you track errors or user behavior consistently?
You need a unified strategy. Maybe share a single instance of your error monitoring script, like Sentry or Datadog, across all microfrontends, or ensure they all report logs and metrics to a central system. You can't easily manage separate analytics for each tiny piece. And for deployment and caching, the advice is usually to host your microfrontend remote bundles on something reliable and fast, like an S3 bucket fronted by a CDN.
For speed and reliability.
Exactly. And you need a smart caching strategy. The bundled code files, chunks, can usually be cached long-term because they have unique hashes in their file names. But that main remote entry.js file,
The one that acts like the manifest.
right, that one often isn't hashed because the host needs a stable URL to point to.
Right.
So you need to cache that file carefully, maybe shorter term, or use e-tags to ensure the host application can always find the latest manifest pointing to the correct version of the remote's code chunks.
Okay, so definitely some complexity there on the ops side too, but solvable with planning.
Solvable, yes, but it adds to the overall cost of ownership compared to a monolith.
Right. Okay, let's try and bring this all together. Microfrontends, clearly they offer a really compelling solution, especially for scaling front-end development across multiple autonomous teams.
Absolutely. And module federation really stands out as arguably the most flexible and performant modern approach right now.
Yeah.
It gives you that runtime flexibility that's so powerful for complex composite applications.
But we also saw that the older traditional methods like server-side composition, they still have their place, right?
Yeah.
Especially for maybe simpler, more isolated page-based splits.
For sure. It's been a fascinating journey, hasn't it? Thinking about how we went from embedding whole websites in little iframe boxes to now dynamically stitching together pieces of UI built by different teams, potentially running different stacks, all seamlessly at runtime.
It really speaks to the ambition of modern web development.
It does. And the
Many-
right choice. At the end of the day, it really boils down to your specific situation, your team structure, your technical needs, how much complexity you're willing and able to manage.
So a good rule of thumb might be, if you're new to this, maybe start with simpler approaches first, and then consider something like module federation as your needs get more complex.
That sounds like very sensible advice. Don't jump straight to the most complex solution unless you really need its specific benefits.
And that leads us to a final thought, kind of building on the source material's look ahead. Given how these tools are still evolving, Module Federation 2.0, supporting more bundlers, for example.
Yeah, it makes you wonder what new patterns might emerge next. As developers keep tackling these challenges, the styling conflicts, the operational complexity, what's the next evolution in building these truly composable web experiences?
Something to ponder, perhaps, as you continue your own deep dives into this ever-changing world of web development.